Hello everyone. Today we are going to look at the series RLC circuit, and we will use lecturing in this lesson. And the objective for today's lesson is you are going to be able to use Ohm's law for complete AC circuit. What is a series RLC circuit? When you connect a resistor, an inductor, and a capacitor across a changing voltage source, you are going to get a series RLC circuit. The current through all these three elements are equal to each other. The instantaneous current will be IR equal IL is equal to IC. When a resistor is connected to an alternating current source, the voltage across the resistor and the current across the resistor through the resistor, they are going to be in phase. So the instantaneous voltage across a pure resistor is in phase with the current. They becomes maximum, minimum, zero at the same time. On the other hand, if you connect a pure inductor to an AC circuit, in this case, the voltage in the voltage of the inductor will leads the current by 90 degrees. When the current is zero, the voltage will be maximum, and the phase difference between them will be 90 degrees. In the case of the capacitor, as you see, when the current is zero, voltage has a negative value. So in this case, we say that the instantaneous voltage across a pure capacitor lags the current 90 degrees. Therefore, we see that the voltage of the inductor and the voltage of the capacitor, they are out of phase. They are 180 degrees out of the phase. When this is maximum, this is minimum. That's why there is 180 degree phase difference between them. Now, to understand the RLC circuits, we are going to now look at the phasor diagram. So this phasor diagram comes from the previous reasoning. As I said, the current and the voltage of the resistor, they are in phase. There is no difference between them. I'm going to represent the voltage of the resistor and the current on the x-axis. And since the voltage of an inductor leads 90 degrees by the current, I'm going to show the voltage of the inductor on the positive direction of the y-axis. On the other hand, the capacitor, the voltage of the capacitor is going to be in the negative direction of the y-axis. Why? Because the capacitor voltage of the capacitor lags 90 degrees by the current. Okay. So, in this case, the total voltage of an RLC circuit is not the algebraic sum of the individual voltages, but it is going to be the vector sum of all these voltages. To get the voltage across RLC circuit, as you see, we are going to make vector summation. These two vectors, VL and VC, are opposite to each other, and when we add them, we assume that in this case VL is bigger, but if VC is bigger, then it's going to head down. Now assume VL is bigger, so their sum is going to be this one. R is in this direction, so if we sum these vectors, we are going to get the voltage of the source. Then from this drawing, we can write that Vs will be equal to square root of Vr square plus Vl minus Vc square. This is the vector sum of the voltages. This is what we are going to do in RLC circuits. So let's discuss, if we have a resistor, inductor, and capacitor in alternating current source, what is the total reactance of the circuit. The resistor is going to show, it is going to indicate some resistance, and this inductor and capacitor are going to show some reactance. So what is the total reactance of this such a circuit? And the total reactance, or the total resistance, maybe we can say, but it's actually not resistance. This the resistor has a resistance, but these two they have a reactance. The total opposition to the current in this circuit is called impedance. So how can we calculate the impedance in such a circuit? Now we know that we can write the voltage source, the voltage across all these elements. This is VR, this is VL, and this is VC. For individual voltages, I'm going to write Ohm's law. It will be I times R. And for the inductor, VL will be equal to I times XL. And for the I'm sorry, for the capacitor, voltage of the capacitor VC will be equal to I times XC. So from our previous slide, we showed that voltage of the source was equal to VR square plus VL minus VC square root, square of square root. So this is VC. Now, instead of all these individual voltages, I'm going to write their values. For the voltage of the source, I'm going to write current times Z. Z is the impedance. It is the total resistance of the circuit. Will be equal to, instead of this one, I'm going to write IR square. For this one, I'm going to write IXL minus IXC square and square root. Now, as you see, we have an I. We have I here, also here. So if we simplify this equation, we are going to get Z is going to be equal to this I, and all I's, all the currents here, they are going to cancel each other. So the impedance, which we show with Z, is going to be equal to R square plus XL minus XC square root. So we showed the voltages, by vector diagram, and these are the sum of the voltages. And similarly, we can do it for the impedance. So since Z is equal to R square plus XL minus XC square, we can represent the R in the x-axis. Okay, so XL minus XC similar to VL minus VC in the y-axis. So if we add these vectors, we are going to get the Z, which is impedance of the circuit. Okay. Also, we can show the impedance with this formula. We know that Z was equal to R square plus XL minus XC square root, but we also know that XL is equal to WL and XC is equal to 1 over WC. This is also a way of showing impedance of the circuit. Also, we have two more formulas. The maximum current in the circuit will be Vmax divided by the impedance, and IRMS is equal to VRMS divided by impedance. These are the formulas that we can use in our calculations. And phase angle in this case, as you see, here is the R, this is resistance, and this is the reactance of the inductor and the capacitor, and this is the phase angle. This angle shows this is the angle between the voltage of the source and the current. How to calculate this phase angle? You can calculate the phase angle, for example, by calculating the cosine phi. Cosine phi will be equal to R over Z. Or you can calculate sine phi. It will be equal to XL minus XC divided by Z. Or usually we calculate tangent phi, which is equal to XL minus XC divided by R. Divided by R. Okay. Okay, let's continue. So let's continue with solving problems. An RLC series circuit has 50 ohm resistor, 4 millihenry inductor, and 10 microfarad capacitor. Find the circuit's impedance at 60 Hertz. And the impedance of the circuit will be equal to, from our previous formulas, R square XL minus XC square root. But first we need to find XL and XC. We know R, it is 50 ohms, but let's first calculate XC and XL. So XL will be equal to WL, which is 2 pi FL equals 2 pi, the frequency is 60, it's given here, and 2 pi F. L is 4 millihenry, 4 times 10 to the negative 3, and calculation will yield 1.5 ohms. XC, on the other hand, will be equal to 1 over 2 pi FC. I'm sorry, this is C. So it will be equal to 1 over 2 pi 60, and C is equal to 10 microfarad, 10 times 10 to the negative 6. And calculating this one will give us 26.5 ohms. Now we can calculate the impedance of the circuit. Z will be equal to R is 50 square plus XL was 1.5 minus XC was 26.5, and in doing this calculation we will get 56 ohms, which is the total reactance of the circuit. This is approximately 56 ohms. And this is A, find the impedance, and B, if the voltage source has VRMS 110 volt, what is RIMS? So IRMS equals VRMS divided by impedance. And this is going to be equal to 110 divided by 56, so it will be approximately 2 ohms. Okay, next question. A resistor, an inductor, and a capacitor are connected in series in an AC circuit. The electromotive force of the source is given by this equation. In this equation, this V0 actually it is Vmax, it is 10 volt, angular frequency 100 radian per second, resistance 200 ohms, inductor 40 millihenry, and capacitor 8 microfarad. What is the impedance of the circuit? Okay, similar to the previous question, first let's find the XL and XC initially. XL will be WL, and it will be equal to 100 times 40 times 10 to the negative 3. It will make 4 ohms. And XC will be equal to 1 over WC, and it will be equal to 1 over angular frequency is 100, and the capacitor is 8 times 10 to the negative 6, because it is microfarad. So calculating this one will give us 1250 ohm. Now it is easy to calculate the impedance. Z is equal to R square is 200 square plus, and XL was 4 minus 1250 XL square root. This, if we calculate it, it will be equal to 1262 ohms. This is the total impedance of the circuit. Now let's go to B. What is the amplitude of the current through resistor? The amplitude of the current means what is the maximum current. Now we know that Imax, maximum current, is equal to Vmax divided by Z, and the maximum value of the voltage was 100 volts divided by Z is calculated as 1262, and calculating this one will give us 0.08 amperes. And this value is same for all circuit elements, and the current through all circuit elements, the maximum current through all circuit elements will be equal to 0.08 amperes. Now C, the next question, the next option, write an expression for the current through the resistor. We know that the current is equal to Imax times cosine WT equals, and Imax we found that it is 0.08 cosine WT, and we know that the angular frequency is 100 T. This is the expression for the current through the resistor. Now let's solve one last example. So it is, at what frequency do a 2 millifarad capacitor and a 2 millihenry inductor have the same reactance? So what is the value of the reactance at this frequency? So it says that XL is equal to XC. Now, XL is WL, or it is 2 pi FL equals 1 over 2 pi FC. And from here, F square will be equal to 1 over 4 pi square LC. And from here, F will be equal to 1 over 2 pi square root of LC. So if we plug in all given values, it will be 1 over 2 pi square root of L is 2 times 10 to the negative 3. It is 2 millihenry, and times 2 millifarad. It is 2 times 10 to the negative 3. So making this calculation will give us approximately 79.6 Hertz. At this frequency, the reactance of both will be the same. What is the value of the reactance? So for calculating the value of the reactance, for example, we can calculate XL. It is going to be equal to 2 pi FL. It is going to be equal to 2 times 2 pi F is 79.6 times L is given 2 times 10 to the negative 3, it will give you some values. Okay, thank you for listening. This is the end of lesson. See you next time.